idea is here to give 9 minutes to each speaker, say whatever they want to say, and then open up the floor for comments. Not so much questions, comments. And of course, since you identify yourself, we're going to put you as a discussion. So I make it more attractive. So we'll be here for the eternity because we upload and we try to communicate ideas. Okay, you have the program, so I don't have to read all the details. Our first speaker is Glenn Bright from South Africa. That's the important thing. He has 9 minutes to impress you. Thank you very much.
I need 5. Am I going to take 5 minutes?
Yeah, that's even better.
Okay, and unfortunately I have to also leave it.
Because we have it online, you have to use the microphone.
Okay, so 5 minutes.
No, whatever you want.
Okay, I also need to
not 5 minutes, more than 5, less than 10.
Okay, so 5 minutes because also I need to leave early. I have a wife commitment at 6:30, so I do apologize for that. But let's start. So curriculum transformation is something we've all been talking about for the last 3, 4, 5 years. COVID made it sharper. And we've all been looking at revising our curriculum mainly because of the 4th Industrial Revolution. The 4th Industrial Revolution is driving us to that. So what we are doing in South Africa, and specifically at the university where I'm at, and luckily I have my academic lead of teaching and learning sitting right over here, so he's going to listen to what I'm going to say. because I'm his line manager, he's going to take this back. But what we are doing is we want to bring 3D printing into the curriculum. So not just having a 3D printer because we print stuff, but the 3D printer must be part of the curriculum transformation. So what are we talking about here? We're talking about a 3D printing farm. So when you think of a farm, you're thinking of cattle and you're thinking of sheep, you're thinking of that. Well, think about that. Take all the cattle and the sheep out, put printers, 3D printers. So when you have a land situation where you have your first years with all their computers, maybe 80 or 90 computers, every single computer is connected to a 3D printer. Okay. At first year. Second year, third year, and fourth year, the same thing. So you swamp all your disciplines with 3D printers. So every single printer or every single computer has a 3D printer dedicated to it. So when a student starts a degree, the student will start the degree always working and always producing a part or parts on 3D printers as they move along. And those parts and those assemblies will be assessed and evaluated as part of the outcomes of the degree for the students. So if we go year by year, first year generally, the students are involved in drawing, engineering drawing of some kind. In our situation, whatever they draw, they must print, and we evaluate that print. We don't necessarily evaluate the drawing anymore, because if the print is not right, well, the drawing couldn't be right. Also, you're bringing the production of a part back into the degree, instead of just having people drawing stuff, getting a mark and then moving to the next level. And that helps industry, because when they go into industry, they really are familiar that the part that they produce must be possible from a manufacturing perspective, from a design perspective. So in first year drawing, they're really printing their parts. Second year, they're into design. Okay, most disciplines are into design in their second year. Whatever they design, they must print. And which is you get the groups together and they print their parts and they assemble them. And these assemblies must work. Okay, so you could have a gearbox where 3 or 4 students all print their parts, maybe a shaft, maybe a gear, whatever. They print it together, they put the assembly together. In second year, it must work. If it works, they're being evaluated on what they've produced. So we brought the 3D printing into the curriculum. Third year, we go a bit higher, where the designs are more complex. Once again, the students all have to print all their designs they do throughout the course, and of course they're evaluated on that. Then when we get to final year, for most disciplines, and I suppose we're talking mechanical mostly here, of course their designs are printed like they normally are, but now we want them to do 4D printing. We want them to look at 4D printing as being part of the curriculum, not just 3D. What is 4D printing? Well, 4D printing is your normal 3D, but you're printing smart materials. Smart materials, or materials are changing their configuration over time, they're changing their structure over time, and that's been brought into the design of a final year project. Then going on to the masters and the PhD, of course, we can extenuate that. So what I'm talking about today, and I want to stimulate some discussion, is 3D printing farms. Having 3D printing farms as part of the engineering curriculum, okay? As part of the redistribution, the recurriculum of the degree programs, such that it's mainstream. We don't just have printers on the side, but printers become mainstream as part of everyday life of an engineering student. And I think that's what I wanted to talk about to you today. I think I've taken 4 or 5 minutes. I'm right on the limit of the minimum time. I think it's something to think about. We all know about 3D printers. We all know what they can do. But have we made it part of the curriculum? And by doing it that, you're bringing the production world back into the degree of engineering, and not just having a simulated engineering degree, not just having a degree where students will, of course, design something on SolidWorks, design something on CAD, and then they say, fine, that gets evaluated. It's not good enough just to evaluate what they do in a simulation. It's not good enough to just evaluate what they're doing in CAD. We want to evaluate the product that student is making. So when they go into industry, they're already on that path. They're not going into industry and then having to learn about the product they've done, not knowing what product they've done, and we want them to be able to take those products, assemble that product, and have an overall assembly that actually works. Because it's no use having engineers going into industry and they don't know how things work. And we're having that problem. We're having that problem where engineers are going into industry and industry is saying there's a mismatch. Your engineers are over here doing their simulations and their CAD and their SolidWorks and over here, but we're over here. We need to produce stuff. We need to add value. We need to sell products. But the engineers you're giving us can't do that. So by taking the printer, bringing it into the curriculum, making it part of the curriculum in first, second, third, and fourth year, and in master's level, we believe we can bring the product and the whole idea of product back into engineering curriculum. And with that, I thank you very much.
Thank you very much, Glenn. Our next speaker last year decided at the age of 35 to become an emeritus professor and start his own business. So collaborate with Glenn because he's a guy that he can help promoting the products that we sell, that we produce.
And I could become an emeritus too at 35.
Costas, you need support.
I have some.
Technical training.
Yeah, I feel like a little bit when I talk to Glenn Bright, he says, I've been coming 20 years, and I was bragging, I've been coming 10 years to this conference. So I feel a little bit senior level undergraduate, okay? So
it took you a long time to get there.
So be kind, but it's hard for me to talk, as you know, just for 10 minutes. So did you say 9?
Yeah, I said 9.5. And we don't give you more time.
This title, the reason I like Atner so much is, and I come back, is because I interact with other disciplines. And a lot of us don't get that opportunity. And I publish papers with other disciplines. And so my work right now, since I retired at university, and I haven't, because it's the interim director, I never let you go. I'm starting this data science institute for machine learning and AI, but I also do a lot of consulting. And when Gregory put this this session together, and these roundtables were amazing before COVID. I mean, we sit and argue all night, but we collect a lot of data now, and and we're collecting what 2.5 exabytes, okay, every day, and the whole human language is only 5 exabytes. So we collect mass amounts of data right now. And how we're using this data in the world of AI, and Glenn Bright, I got some discussion for you later, how machine learning and AI can help us with design and 3D, 4D printing, pretty amazing stuff. But humans are not learning fast. And many of us believe we've already crossed this threshold. Okay, so this is projected 2025. AI and robotics is learning very quickly, and many of you know that. So the theme of my talk was about human activity in the manufacturing sector. So the last year and a half, or 2 years now almost, it's been doing a lot of consulting. I go to a lot of manufacturing facilities. Guess what I see? Less and less humans. I've seen that over the decades in my career too. And it makes sense. Humans are not good in manufacturing environments. Ergonomics. Repetitive errors, human error, okay? A robot will make that error more than 2 times if it's programmed, right? Okay? So human activity in manufacturing, I think, is going to become almost extinct. And there's companies I work with now that are trying to go to what's called a lights out plant. No humans in the plant. Now they're failing on a couple of their first attempts. But if they're trying, it's a little bit like Elon Musk, right? In Starship. So every launch, I mean, it's expensive, $1 billion, but every launch he gets a little farther, right? So I think it's going to happen. And I think data, back to this thing here a little bit, I'm a little bit ahead of myself here, but this whole sustainability perspective, I think the world of machine learning and AI can take in directions we haven't thought about. We have to solve problems that we haven't thought about, okay? And the humans are limited there. However, we have to deal with this, okay? Fascinating data here. That one really surprised me. The global sea surface temperature. And I work a lot with data signatures and statistical process control, okay? And the gray here is the historical. Well, we are actually driving this process, what we call in manufacturing, out of control. So our planet, from a temperature perspective, has become unpredictable. It's become out of control, okay? It's become unstable. So we have to deal with that in the context of the world we still exist in. And back to my thought here, machine learning and AI can help us maybe solve some of these problems, okay? So I'm probably going to leave it here. Next slide. No, I'll leave it there. I think we're here, you know? I think we're too slow to learn, okay? Humans just are not good learners. And actually, there's some interesting papers out now about we're actually going the wrong direction, humans. And if you look at activity of generation alpha, is anybody 18 or under in here? Generation alpha, they look at work completely different in the world of AI and machine learning and technology. Okay? So this person here is going to become much more difficult to interact with machines because of their limited capability as a human to process this data, okay? So I do believe machines in manufacturing are better than people, and companies know this. And back to Glenn Brightstand, and that's a good way to segue here. He talked about the 4th industrial revolution, and now we get to the 5th. Well, the 5th industrial revolution with humans, relative to manufacturing, they don't exist in manufacturing sector. Maybe they shouldn't. But then what happens to human activity if we no longer exist in a manufacturing environment, okay? And this is just an example of one of the facilities I work with. And I'm lucky if I see 2 people all day in that facility. And it's a manufacturing facility, okay? And I'll leave it there. Maybe that's a good place to stop right now. So stimulate a little discussion.
Thank you very much. I have Pavel here. So the next 3 speakers, they have a family name that I feel very comfortable in announcing it. Because all the others are usually embarrassed. Our next speaker is Theodore Strafalis. He's professor at the University of Oklahoma, but he will remember as our head of our industrial unit. We have 10 minutes to Kostas. We need support.
Just minimize it. But I leave this.
So AI doesn't help in the presentation.
No, you see humans don't do good on this.
They know advanced things. They don't know how to walk.
Oh, yes, that's good.
Okay, I think the next speaker, originally my title was AI, Science and Engineering, Education and Research, but then I thought I can talk forever for this topic, so I selected a very specific topic of AI. So I'll talk about generative AI in an educational setting. Actually, this story started last week because I'm teaching a course in financial engineering analytics, and we would like to explore for the first time. I'm teaching this class every summer for the last 7 years. So we thought that maybe it's a good time to start exploring generative AI in this course. So what is the role? The question is, what is the role of Gen AI in engineering education? So I'll be a little bit more general, and then I'll focus to the specific course with a very simple example. So the big picture is that Gen AI can give both students and instructors powerful new tools to produce and decode text, code, images, and more. So, like other tools, these capabilities can be seen as enabling technologies in the classroom. So, in the next few years, I think Google will disappear and it will be replaced by Gen AI. It will take some time, of course. So I would like to talk a little bit about that. So I'll give a fast definition of the basic concepts, and then we will try to discuss the ideas of tailored education, how we can use this in engineering education, some limitations, and what instructors can really do. So what is generative AI? It's basically an umbrella term for AI systems that can produce and decode content in various modalities. So those systems like ChatGPT, all of those belong to the so-called large language models, LLMs. And these systems use various architectures to build models, and the models can be incorporated into more complete software systems that can interact with end users. For example, ChatGPT is a product that uses many underlying models to achieve different modalities and different speeds, and the specific GPT-4 is based on the so-called transformer architecture in neural networks. So many of the mainstream Gen AI products allow users to create text and code, while at the same time are able to decode and interpret text and code supplied by the user. So this is a big new development, exciting development. For example, a student could have powerful summary capabilities with course material by prompting with specific task questions. Then they could have a model to generate example code as a way to apply the course material for other projects. For example, here I took my class, the specific class I'm teaching. So basically, we consider the so-called asset pricing PDF. It's basically my slides on a specific module of the class. And then we ask ChatGPT, create a single paragraph summary of this slide deck. This is very helpful for the students because they can see very effectively in this few lines, a description, a summary of the course. And then we ask, what are the top takeaways from this deck I would need to know as a student? And then the answer was, here are the 3 top takeaways from the asset pricing and portfolio theory. And then you can see what are the basic concepts that the student must understand: understanding rates of returns, time value of money, etc. So then we ask to develop a code. So we ask, generate a Python code to illustrate the main point of the deck from the capital asset pricing model. And the answer was certainly, here is a Python code snippet that illustrates the main point of the capital asset pricing model. And then we ask another question. You see here the code actually, which is spectacular. And then we ask, now pull data from Yahoo Finance on some stocks and show them on the graph. And then the answer is, as you see, to pull data from Yahoo Finance and plot the expected returns using this CAPDN model, we can use the specific library that explain. And then we ask, and the system gives us the complete code, and also you see the specific graph here related to this example. So this simple example shows that the student now has the power to tailor their understanding of the target material. And then, for example, continuing from the previous slide, if the student was only previously familiar with a specific language, like R, and he wanted, for example, to transition to Python for this project, they could ask the following. I have only ever used R, can you explain what P is and any parallel to R? And of course, we have the answer here. Certainly, P is a package manager and so on. So it explains us all the ideas about that. So instructors can point students to both commercial now and open source resources, and many open source models perform similarly to the current state-of-the-art commercial models. Instructors, departments of universities should host actually Gen AI systems for use by students in their courses, as many of the powerful models are actually costly subscriptions or require powerful GPUs to run locally. So here we have some possible options. On the left we see some commercial options, and as you see we have some pros. We have fast inference, integrated product offerings, and then we have some cost. No privacy guarantees, that's the big problem nowadays. We need privacy, and then expensive subscriptions on pay by use. Of course, we have the other options, the open source options, which give us a lot of capabilities, and there are some pros, can be cost effective. And then we have also local privacy, something very critical for us. And of course, there are some cons. So they need some experience to deploy, and they have slower inference speeds of commodity hardware. So yes, I'm finishing, yes. But there are some limitations. Not all models are created equally. So a big problem here with these models is the so-called hallucination. So those models are based on the idea that they predict something with high probability, so they feel that the answer is correct. But sometimes there are mistakes. So we have to be very careful about these hallucinations. And also the issue of homogeneity of generated content is very critical, especially in GPT-4. So, summarizing, instructors and students need to jointly understand the role of AI in education, and the instructors should create course content, knowing the technology available to students. This may mean making courses a little bit harder for the instructors, and routine tasks in both text generation and code generation can be done trivially by AI, so make the students operate at a higher level. Students should be encouraged to supplement their learning of the course material by engaging AI with their specific questions, and the educator must take the lead on enabling access to AI systems. So I don't have more time,
Okay, our next speaker is Professor Dimitris Goulias. He is from the University of Maryland. It's important to note here that first, he is the head of our civil engineers, and we organized a study tour for the last 6 years. So you are more than welcome to send the students, if you have students that are interested to study sustainability and infrastructure in Athens. It's the University of Maryland in collaboration with us. Plus, just to give you an idea that we can organize study tours. So, Professor Goulias, you have 9 minutes to impress the world.
All right, 1 minute is just my name.
Nobel Prize winner. Unfortunately, we don't have that in engineering.
All right, what great topics. Thank you for organizing. Just one more time. You see, AI took over. It took over. It's going on its own.
That's the
You know,
problem.
The best thing that I heard in this conference is, how do we know that we're not the creation of an AI and we're monitored from someone else?
Exactly.
Okay. Can we prove that?
Full setting and control arrow. Full screen.
You put two engineers together to solve a problem, Olga and you.
I'm ignorant. I'm ignorant of AI. Even though I do research.
You need an economist to tell you how expensive.
Okay, Olga is good. All right, no. All right. So, just for the time, I'll start. So, great topics. What we heard so far is what all the academia is dealing with. What to do with our curriculum, how do we incorporate these tools. We cannot neglect them, we cannot ignore them, but we have to adapt into it. Our students sometimes they're cleverer than we are, as Professor Pavel said, and so we can always, I guess they're born with computers and with programming and so on, so clearly we have to face the reality of what's happening. I'm afraid to stop. Stop. Let's see how we do. All right. So the question is my topic. Let's see if we can do something else. Just targeting this one.
What's now? Where's Costas? Because we have a problem with the PowerPoint.
Just enlarge the.
Why would you save it as a PDF? That's another option.
Why translate? I think we have an option.
It was online. I sent it online.
Is this the problem with human activity here?
Yeah, you can use it for here.
It's good to have slaves here.
All right, that's fast.
They need to produce.
They
need to produce.
So the question is, we are facing in engineering and sciences is, first of all, we're living in a global environment, and nothing new there. But what are the issues? How the curriculum should address these issues? And this is a list I'm not going to go through: natural disasters, ecology, natural resources, depletion, multidisciplinary aspects. All of these are in our thoughts when we try to educate the new generation of engineers and scientists. The other part is social issues, and becomes more and more evident. Whatever we do, we have to have inclusion, diversity, and eventually opportunities at the global environment, not only for those that they can afford economically, but also for those that they cannot. And so all of these things are in our mind in terms of creating the new curriculum. So in Maryland, actually, we approved this, the strategic plan, we approved that a couple of years ago, which we thought, how can we address the societal needs of engineering today? And so, of course, resilience and sustainability is in the forefront, and so everybody then says, okay, I'm a structural engineer. How I will work in this environment? I'm geotechnical, I'm environmental. And so clearly you can see the three circles. I read, if you cannot look into that: intelligent transportation and mobility, environmental and health. And each one of us, and we are all familiar with all the traditional pillars of civil engineering, eventually fit into one or two of these circles, and the common denominator is there is a common area of research, of education, that eventually fits into resilience and sustainability. Those of you that are exposed to resilience, forget about how we're designing a building for so many years. Forget how we're designing about a highway. We are going to experience flooding. We are going to experience hurricanes. How do we minimize the impact so that eventually we can put the structure back in service very fast? Why? Economic implications. If you have economic implications, you have social implications. So the whole idea is we have to change it. And of course, other things that have bothered us is, okay, we have the mechanics and the physics and so on, but a lot of our work as civil engineers now go to data analytics, big data analysis. We heard about AI, we heard about risks and so on. So eventually these are tools we can use for creating the next generation of education. So this was our strategic plan, which now, as I mentioned, has been approved a month ago into a new curriculum. And I don't have the details, a lot of back and forth with the more conservative faculty. I want my structure courses to be there, don't touch them, or things like that. And so eventually we gain ground and move into. So global issues should be there. We should address sustainability. We should address resiliency. And so eventually, how do we do it? And that is the big elephant in the room. And obviously, you have to do it at the undergraduate and graduate level. And so you have two options. One is to do it on campus, traditional courses. You have the other option is education abroad. And we're lucky enough that our presidents, for the last three presidents actually we had, they were convinced that 100% of the Maryland students should have an international exposure. If it's global environment, they better go out of Maryland, go out of the country, and see what's going on. Is it an internship? Is it a short-term program? Is it a long-term program? Is it a semester? Whatever it is. And so that has helped us really now to put everything together. This is just some statistics. 3,000 students every year go abroad from the University of Maryland. $1 million of scholarship. And all these are statistics. And so I bring now the issue of the non-traditional education, which means on campus, abroad. And that's what we're working with Professor Papanikos and his team here. How do we make it reality? Why we should go abroad? We can do these courses in Maryland. There's no need to come abroad. Yes, there is a need. And the need is you have real case studies or projects that actually can give you a lot of stimuli, combined with a cultural diversity, right? If you talk about to an Italian, you have an old building, and the United States, old building, demolish it, build a new one. Why? Because the cost is 2.5 times the cost of the new building. If you talk to an Italian, to a Greek, say, oh, that building cannot touch it. Someone was living there 3,000 years ago, 2,000 years ago, 100 years ago. That architectural feature you cannot eliminate. And so we start seeing now this global, multicultural aspect of education that otherwise you will not have it when you design a new project. And because eventually our students will be, of course, working beyond the border, whatever that means, eventually we won't take advantage of that. And so we run programs around the globe, from Australia to Africa and so on. The one that I'm responsible for is Greece, Italy, France, and Czech Republic. And as I mentioned, I'll take eventually later on as an example the Greece program, the one in Athens we work with Athene. So right now, the three hottest areas that we are working in countries, the first one is sustainability, thermal comfort, and safety. Right now, we talk about green areas, etc., but me as human, how does it affect me? If I'm in a park, if I'm on the road, what is the impact on myself? And so yes, it's nice to look at a little bit about the global, the buildings, the infrastructure, but in terms of the human impact, how do we measure it? How do we quantify it? The second aspect is climate change, the smart green cities. We're all familiar with Paris, the Green Olympics. We're all familiar with all the new plans that they have, of course, for addressing the climate change, etc. And of course, Greece, I mentioned that even in the morning, has unique examples of massive projects. The Niarchos, just a building, $600 million, euros. The Rio Anterior Bridge, a bridge that actually can move 2 meters without failing or crashing or anything like that in terms of resilience. So ideal locations for bringing the education abroad, expose them to real case and develop their own projects. So you use the theory and the principles to actually build environment to be able to do that. And so this, as I mentioned, this is an example of the program in Greece, where we are going, what we are addressing principles in Maryland, all the theory, all the tools are done there, we don't have the time here. And the second part is abroad. What are we going to do? What data we're going to collect? What projects they're going to look into? And how to develop their own solutions. And of course, then you say, wait a minute, now is this education abroad or traveling abroad? And so you still have to meet the ABET criteria, right? And so you have to have some accountability. So learning objectives, explore, analyze, examine, learn, apply. This is the Niarchos, for example. This is the Rio Anterior Bridge, how they have done it. This is the Elliniko project, a massive, massive project. in terms of sustainability. Learning outcomes, dealing with decision making, design alternatives, materials, etc., etc. Everything should be there. And this is the different activities we organize with Athénée, from site visits, field trips, to guest speakers. Again, how do you expose the students to the real world and taking action, doing their analysis in real case scenarios, not anymore abstract. And so we start with the big pictures. Every city now has these big plans. These are the plans for, of course, Athens, Greece. From the Rethink Athens, the resilience, there are 100 cities that they have subscribed to generate a resilient plan, not only infrastructure, but economic and social. So the city of Athens have done that. C40 now, there are more than 100 cities on that. And of course in the European Union, the Green Deal Initiative. And some of the specifics of where we go, what we do. Again, the type of projects that the students get involved, collecting their data and using the theory and the tools we have already taught them in Maryland to do their projects. And then finally, academic expectations, they get a credit, it's part of the curriculum. That's to give you an idea of how can we pass from the typical classroom environment to real case scenario, and how to incorporate sustainability and resilience to the curriculum in an effective way, not just theory.
Thank you very much. Okay. We are sick and tired with the engineers dominating the symposium here, and we're going to change and move to Professor Zachariadis. He is the director of our Health and Medical Sciences Division. They have their own conference at the Coron here on public health and health economics. So I asked him and he accepted to impress us with 9 minutes speech. He's here.
Who is the next speaker, by the way?
The next speaker is over there.
Where, sorry?
Here.
Put your hand up. You're the next speaker. Okay.
You gotta take his time.
What's that? No. I just wanted to clarify that I'm the oldest, most experienced, and wisest faculty member here, so that's why I wanted to.
We are very young. We are very young.
No, on the contrary.
Only Timothy Young, I think, is younger here. By name, not nothing else.
So I'm going to take the mantra, tell them what you're going to tell them, and then tell them what you told them. So there's a lot of discussion about AI and all the great things it's going to do. And I'm just going to put a downer on that right now. I'm going to talk about how AI was used by the big, let me see if I can on there, the big giants. Ooh, this is not what I was hoping to get on there, but that's okay. This is the wrong presentation, but that's okay.
AI got you. You were going to talk about
the big companies, big social media companies have been using AI for a bit longer than it was out in the public. I mean, they were part and parcel of who had developed AI. So just like those of us who go into casinos, and casinos have strategies to get us hooked into gambling, the same strategies are being used by social media giants to hook young minds into the cyberspace, into doing things that they are not just not supposed to be doing, but getting addicted to aspects of life before their minds are mature enough. So this has been so disruptive in the educational space, both in grade school, middle school, high school, and now into university, with this epidemic of mental health illness that is occurring. And this is where perhaps there's an example of AI being used not in such a good way. So educational institutions, from school boards to universities, and now the governments are getting into suing these big companies, these social media companies. So the timelines, is Costa around? Because I just want to see if he's...
He should be, otherwise he's not going to get paid.
No, that's okay. No, I never said that. But
Costa!
Just to give you a sort of, let me see here.
He's coming.
No, that's okay.
He's running actually.
That's,
He thought that we are doing AI, that we know it.
I won't belabor the point. The message here is if you look at the dates of when these lawsuits have been filed, these statement of claims, we're talking May 29, 2004. That's less than a month ago. April 2nd. Okay, so this is filed by educational institutions against social media companies. So school boards across Canada and the United States are coming one after the other, suing these social media companies for the impact that it's had on the kids and the resources these educational institutions have had to implement to save these kids from these digital addictions, as they describe them. April 2nd, Thompson Rivers University highlights the legal actions here. National Post discussed the allegations of brain hacking by social media companies, so brain hacking young minds. April 7th, the CBC covers and the BBC covers the mental health crisis linked to social media use among students. And The Guardian reports on the exploitive business practices of social media companies. So let me fix this so that, you know, if I can't see it from up here, I can't imagine. But I'm much older than most of you, so that's, okay. Anyways, I sort of want to point out here, there is a lawyer in the crowd, and the lawyers are supposed to be using this sort of, it's not the right presentation, but that's okay. There were two presentations, we downloaded the wrong one.
Okay.
No worries, I'll work with this. It's not formatted the way I have it liked.
You can change, can you?
It's okay, it's on my computer.
Yeah.
The challenge, the challenge, yeah, the challenge here for the plaintiffs is that, you know, what framework are you going to sue these social media giants who have tremendous resources? This morning we were talking about that tobacco is spending $660 million on legal fees to protect themselves. What is $660 million to Meta, Google, Instagram, WhatsApp, TikTok? So their resources are even far greater than big tobacco. So what they're describing, or the way they're going about it, is that social media, as it's designed to hook kids, is actually a public nuisance. Claiming that, you know, they're resulting in attention learning issues, a mental health crisis, distraction, social withdrawal, and cyberbullying. They've created a public nuisance akin to environmental pollution we were talking about earlier with food production, significantly impairing students' right to education and well-being. So constantly they seek changes to the algorithms to make them less addictive and demand compensation for their resources spent addressing these issues. So it is what they said, there's algorithms. And these algorithms have been improved and made incredibly efficient to hook kids. Kids that then in class can't pay attention, they're constantly on their phone, they're in conflict with their teachers, they have to be sent out of class, they have to be dealt with. So schools are dealing with this in a very major way. Now schools don't have the budgets of these large social media companies. So what's happening here is like New York State, New York City and New York State are actually, now governments are starting to sue these social media platforms. Because when the schools can't deal with it, it goes to the public health community groups, okay? So to the city and then to the state, or to the city and the province and the Canadian setting. So here, New York has filed, its Department of Education, filed a statement claim against TikTok, Instagram, Facebook, Snapchat, and YouTube. And they're saying the social media platforms are fueling a nationwide youth mental health crisis by designing addictive and manipulative programs. So they're hoping to get these tech giants to change their behavior, holding them accountable for their actions, and recovering the cost of addressing these things. So their argument is if you don't actually get the social media giants to pay back into the system, they're really not going to make any change. And that's going to be a big challenge because way back when the internet, the .com world had been created, there was actually some legal immunity that was provided to these companies. And that law hasn't changed. And that is what these social media giants are saying. What we're doing is actually within the law. We're not actually breaking the law.
So we'll
we're
change the law
protected.
now.
What's that?
We're gonna change the law, so it's outside the law.
Well, that then goes to the Supreme Court of the United States of America, and, well, that's another conversation. What's that?
You cannot change the rules again during while the game is being played.
Yes, that's
Or
perhaps part of
second
it.
round of the game.
Yes. So impact on students, the distraction, the social withdrawal, the cyberbullying, tremendous things. Kids committing suicide, even educators now committing suicide into this picture. That's being discussed about how stressful the job has been on them. So in reading all these statements of claims across across Canada and the US, I'm not sure what's happening in the European landscape. It's actually quite disturbing. And again, there's stigma associated with this, so it's not yet quite out. But if you start going a bit more granular into the media, you see these families describing what's happened to their loved ones. And we're not just talking the 13, 14, 15-year-old, we're talking the 20 to 30-year-old, okay? And even older ages. Okay, arguments. I mentioned already the public nuisance and addictive algorithms, demand for compensation. So I'm telling you what I told you, and then I'm going to tell you again. The counter arguments. So here is actually something that the American Psychological Association put out. Their health advisory found that using social media is not inherently beneficial or harmful to young people. Harms caused are from other factors like the impact of COVID-19 on students' mental health, remote learning, or strained academic resources. So you can imagine social media has latched onto the one argument, saying, hey, look, America's psychological experts are saying it's not us. We're neither harmful, but we're not even beneficial. We're just neutral. Okay. Snapchat went as far as to say that it is happy with the role it plays in helping friends stay connecting during adolescence. It emphasizes the positive social connections that its platform fosters. So imagine twisting something that they use to addict children and young adults, that then goes into being expressed as something that is positive. Expert opinions, ignore who those are people. Anyways, they're designed to maximize user engagement, often at the expense of mental health. The addictive nature of these platforms can lead to significant psychological issues, including anxiety and depression, and as extreme cases of suicide, or even violent outbursts. The direct correlation is there between excessive social media use and increased levels of stress and social withdrawal in adolescence. It's imperative that we address these issues at both the technological and societal levels. So the point being made is that technology has advanced so much, but we have not actually prepared the youth for this rapid escalation. And I've used this example before. When my first child was born in 2005, I had 5 devices. I had, a flip phone, I had a camcorder, I had a Palm Pilot, if anyone remembers what, I don't think any of you are old enough to remember Palm Pilots, but anyway, that pager and so on. And then in 2011, when my youngest was born, I had an iPhone. It did everything. It was my pager, my Palm Pilot, it was my calendar, it was my... So in that span of 6 years, there was a rapid change of technology.
George, you have
Yes,
1 minute.
1 minute, okay. So conclusions and future steps. I think we know what needs to happen if those of us who are in this room, who have children and grandchildren and so on, I think we just need to be aware that this is happening. Take a position, lobby it accordingly as engineering experts and AI, as physicians and public health and so on, because eventually this is actually the next generation and future generations. So we don't know the impact what AI is doing. Like we see, or we can speculate on all the great things it's doing, but we got to also be prepared about the negative things or negative impacts it's having. And I just want to highlight the mental health issues through digital addictions on youth, because there's not going to be healthy, mentally healthy, young undergraduate and graduate students to do the great work that many of you here are talking about. So on that note, thank you.
Okay, our next speaker is a very important speaker because he's the last speaker, so it's over the whole thing. And You have 10 minutes, Evangeline, to impress the audience here.
I don't know if I will impress after the medical.
Yeah, I should say about the judge something different because he's talking about public health, his area, and that brings different ideas into this discussion with engineers. But we're going to close with an engineer. There are more engineers participating in this weekend on the public health, that's why they dominate this.
So I have been asked to be on
You
the
have to use the microphone for the...
I have been asked to be on the round table, okay, discussion regarding my opinion about engineering, about education, and so on. Politely accepted, and thank you, but it doesn't look like a round table discussion on different topics. However, it's a great opportunity to let you know the frustration that we have in the United States regarding the engineering, regarding the civil engineering in general. I don't know what's going on in civil engineering in Europe, okay, but in the United States, the enrollment is declining, especially in some areas in civil engineering, so we have a major issues to deal with. My name is Nabil, and I'm a professor and chair of the Civil Environmental Geomatics Engineering Department in Florida University in Boca Raton, Florida. Florida has 12 public universities. We are one of the 12. Unfortunately, we are not the two flag universities in the state, so we are facing a lot of issues, a lot of money-related stuff that we have to deal with. So right now, my department is around 397 students in 3 programs. We have 3 programs, civil environmental geomatics, and we have started discussion a long time back about the courses, about how we are going to recruit students in our field. And to be honest with you, I have 3 kids. 2, they are following the medical field. 1 is still in engineering, maybe will be a captain in the merchant marine, but many families in the United States, they are looking where the money is, okay? And when the data science major, they are coming out of the school to $200,000 or $200,000 more in 12 months, is a very critical for us to compete. So outdated courses that we have in our field is really an issue. We are teaching strength of materials from 1950s. We can never change it. Okay, and we have faculty that they are very, very good in their field, but they are not familiar with the technology, and they are not familiar with the social media that I heard earlier, and definitely they are not familiar with the AI. Okay, that everyone is looking. Okay, now everybody is looking for AI. Machine learning is the new candy that we are playing around. So as a faculty in overseas, we need to get money. Something when I was a student, I was working in AI, but it was not a big deal. Yeah, I was doing, operational research in simulated annealing algorithms. That was part of AI, but was not in the level that we are dealing right now. So the other issue that we have is with the online courses or hybrid courses that is very difficult, okay, to bring the research finding from our work, our new knowledge, to bring it, in the classrooms. I don't think that many schools in the United States, they are really ready to offer online courses. Let me take it back. I don't think that many schools in Florida, they are not ready, okay, to offer online programs, online courses. And also, when we are offering online courses, I think major thing is the cheating. Second thing is no participation. You can be in the restaurant, you can be at the Napa beach in Cyprus, that I don't think they are learning. And we have a major reason right now with the COVID era students are graduating that I don't think they have learned anything in, all they have learned enough during these 2 years that are the COVID. I have kids that they graduated in 2020 that they got the A, but it's questionable how they got A. So we need to bring, we have a major discussions on the national level, but at the state we need to bring research in our teaching. We need to involve the K-12 from summer camps from a long time back to recruit the students in our field. So the next between research and teaching has been drawing the attention of academic for range of scientific field. We would like to sustain because the money that comes to the schools from the state is based on the FTE. You produce, you graduate, okay, you are getting the money. You don't have the money, you cannot update your laboratories. It's a major issue. It's totally different, from Greece. I don't know, but I was a student. I think the money was coming from wherever. Doesn't matter how many students you graduate. So the other important thing is that I'm behind is the social media that many researchers, many students, when they are doing some research or they are presenting on the Atiner or any other conference, they post it with I'm very proud, this and that, something that we as a faculty, we need to follow and we need to demonstrate to advertise our research so we can advertise our research with modern technologies so we can attract students. So the other important thing that we have discussed many times is how to improve our websites, our social media, so we can attract students from the state or from the different states or international. I keep telling them I am with a university, as a faculty in Florida from 2006, and I was keep telling them that because I graduated from University of Maryland, that one of my colleagues, a PhD student, developed in a few months a website, long time back, that was on the point, on advertise the research component of the faculty at the University of Maryland, something that we are working on in Florida after 20 years, that we saw the curriculum, we saw this and that, that's actually, as a parent, okay, we are going to get 128 credits to graduate. Credits, yes, to graduate, but how much money? Okay, how much money my son or my daughter is going to make it? It's possible to be placed in the job market immediately and so on. My university, FAU, I employed at my university, is on the top in the state with
2 minutes.
I thought you are.
Yeah, that's what I'm going to do after the 2 minutes.
That's exciting.
So, how to improve the curriculum is really important, and also how to bring research in our courses. Whatever we are learning, from our research, we need to bring it to the classroom. Also, to be able to develop the right tracks for the workforce development. So, on the research component, here are some example on the left. Yes, on the left, that students that they are presenting to graduate students presenting to at the graduates in different labs. Also, we are bringing K-12 students during the classroom, during the semester, to participate, when the instructor teaching particular subjects. We have different steps: research-led, research-oriented, based and tutor, based on specific, group student needs. and always we are bringing team projects. First of all, we are bringing projects, in the classroom, and also we have team work. Something that we have faced, it is a major problem because it's not that they are not working as a team, but they are trying to escape and they are not taking this seriously. We are working on it. Before I will complete that, we have 2 seconds where we will never be a faculty, whatever be, as a chair, we will not praise the students. Here's an example for my team, that I have in the transportation research group. With that, thank you. And,
thank you very much. I'd like to thank the last speaker because he followed my letter that I invited him to speak, and of course what we're trying to do is doing something about world education. Now the idea is that because some people complain why I call this round table, because I cannot find any other term. Someone came and said he didn't like the round table because the table was not round. But that's conceptualization. But if you come up with a new term, a better term that describes what we are doing, I don't want to change what we are doing, change the name. So if you come up with a better name, given that what we are doing, then more than welcome to adopt. Maybe if it's a great, I don't like the word symposium to use for this one, because it's more than, I think it's different, but anyway. Now, we don't get questions for the speakers, but we get comments, and you have 1-2 minutes if you want to answer something, rather than asking, because it's not a research paper that was presented, it's just their idea about how they view the future of education and research. Is anybody that feels this internal eagerness to speak and enlighten us about what's going on in education and research? Okay. Should I go by age or by gender? What is the rule here?
Video me.
Yeah. He discriminates against women.
Myself.
Because now the tradition is not to give priority to women. Okay? Go ahead.
Exactly. Hi, Laura Fox with Vermont Law Graduate School in the U.S. I don't know if I could keep it to 1 to 2 minutes because there were so many thought-provoking thoughts shared. So thanks, everybody.
Outside, please.
Yeah. Okay.
Take a 2 minutes here, and then you go outside and speak forever.
So my cover was blown earlier. I'm a lawyer, and I primarily I primarily practice environmental law. So when I heard 3D printed farm, the red flags go off, and I think, oh God, how much energy is that going to use? And then I say, okay, let's assume it's going to be renewable, but the water resource is really intense, right? So just encourage everybody to think of when you're bringing these technologies into the classroom, the environmental burdens associated with them. I really appreciate you saying that AI is going to solve the sustainability issues. I hope that's true, because I know humans aren't doing that right now. The thing I struggle with bringing AI and generative AI specifically into the classroom is I feel students, especially law students, need a foundational understanding of various skills, right? I'm sure engineers do, especially civil engineers need basic physics understanding, right? So how do you balance between exposing the students to the tools versus teaching them the foundations and then building upon that and exposing that to the field? George, I assume you meant the Communications Decency Act when you were talking about the immunity that these platforms were given. I would encourage you to look up a lawsuit that I brought on behalf of a number of consumers against an internet marketplace called Puppy Find. They were selling, peddling puppy milk puppies, and the consumers were getting sick and dying dogs, and they tried to hide behind the CDA, and we beat that immunity. It was in Arizona, so hopefully that continues to be a trend there.
Right, so.
George?
Thank you. Thank you. No.
I
I want to get that 3D
Can you identify yourself for
Yeah,
them?
Pavel from Western Michigan University, USA. So I'm going to clarify what Timothy was talking about, 3D printing. I have my personal experience for 21 years. I always do that in my class, 3D printing, and I discovered something very...
I think Glenn talks about it.
Oh, sorry.
That's okay. But he left. So talk about Tim.
Yeah, sorry.
No, he excused himself. He said he got a meeting because he had a meeting.
So it's he was talking. So I can represent him. I put the wrong color last time.
That's okay.
So 3D printing. Everybody's fascinated. Kind of my specialty right now, and have been 21 years. The problem with students like using 3D printing in education, well, everybody uses 3D printing. It's kind of copy. We just go and copy somebody else's work and print it out. This is not a learning process. This is not like you're doing something and try to impress somebody, but you go and get something ready. So I give my students, and they are seniors usually, to design, to build something, and what they do, they just go and copy from someplace. So we have to be very careful when we propose something, new technology, which I completely agree that is a good one, that how going to actually prevent this to happen. Because now with AI, I say, hey, design for me, let's say a chair, and make some modification. And boom, we have a chair design. How we prove that this is a student work, or this is the actual something was happened modification on AI, which we have. So we have to think when we propose something new, do we have facility, do we have capabilities to prevent this kind of copyright, or I would say that cheating, that's why I say very simply cheating on this technology. Because let's be honest, I'm a professor and I think half of you are probably the same situation. We're a little behind our kids, right? Or our students in that technology. So they're much faster than us, not only how to use it, but also how to cheat using it. And then we have to be in front of them when we propose new technology to use it. Can we prevent, or can we actually use technology for learning? That's my comment.
Yes.
Okay.
Name, where are you staying, your phone number, everything.
My name is Dillip.
We know that.
Okay,
Be careful what you say.
my name is Dillip. I am from South Africa. Okay. I have 2 points of concern. One is generative AI in the education space. We understand that this is very, very important and it has a lot of benefits. But as engineering students, an engineering graduate need to be competent in many skills or many attributes. Now, generative AI is making them not to think. Idea generation is fine, but they are not thinking to generate ideas. Second, if they need to competent also writing codes and solving the mathematical problems. But if, as a professor informed that you can have a code, generated Python code or MATLAB code, and the student is just putting the, putting the data, and garbage in, garbage out. So student is not really learning. But at the same time, it can generate a lot of ideas. Now, we do not know as educators. And I am flooded with a lot of concerns from the academicians that this guy is cheated, this is going to doctors and all sorts of things. How to solve that? We are not discarding generative AI, right? But at the same time, it's becoming very difficult to implement and make the students competent. The second one is much more, it's running for a long time, integrating sustainability and resilience into the curriculum. Now, we have been talking about it for the last 20 years or so.
That's Professor Williams, he's here.
Yeah, we are talking about it for the last 20 years. I'm from India. I was talking about it 20 years back. And in South Africa, I have been working for the last 15 years. We are talking about it. But until now, we couldn't reserve where to put it. Where is its space? In a particular module or in a particular curriculum as a standard of our module. And there is no unanimity. We try in tidbits, like in small way, but it's not working. Now it's time to find out where.
He's going to answer to you outside the corridor. No,
No, that's not answering.
Yeah, okay.
At the risk of knowing that
Everybody
my name is Atalah from Bowling Green State University in Bowling Green, Ohio, in the US. At the risk of being the last one who's holding you between dinner and taking a break after a long day, I have a few comments. at the ground floor level. When we talk about restructuring our curriculum, the challenge is that we have a lot of competing demands on our curriculum. We are limited to 120 hours. General education requires a good portion of it. 40% of it is going
credits.
Yeah, 120 credit hours. General education is a good portion of it. We cannot. So, civil engineering. Take civil engineering. It's a huge field of study. Which one would you cover and which one was not? You know. So I think one answer fits all is not. Maybe you have a strength in sustainability. Maybe you have a strength in another area, and schools can develop areas of strengths and develop. But to try to cover everything is the second comment that I want to make related to AI. AI serves the master of the AI. It's not the public, as we saw in the social media cases. If I'm the owner of the company, I want to design, and I'm paying for it. I want to design an AI system that serves my interest, not necessarily the public interest. I think we are having the wishful thinking that AI will solve society's problem. AI will serve the interests of the people who pay for it, not the. So if there is an interest in sustainability, they will serve sustainability. If there is an interest in pollution and defend them and protect them from pollution, they will serve that interest. That's the second point I want to make. I forgot the third point because I'm an old man.
Maybe we didn't have a third point. So you forgot that we didn't have a third point.
My name is Chen. I'm from the University of Manitoba in Canada. So I just want to comment on AI. So for AI, like Dr. Yang mentioned, it's super good for industries. My son working for industries using AI as a tool to increase efficiency. I heard the number, the industry people saying the efficiency can increase 500% in average. For some industry, they even increase 1,000 or 5,000. So it's huge. So AI is not going to be avoidable. It's going to be a tool for industry, particularly manufacturers. So back to AI for educational. I think we should be careful. So I'm teaching engineering too. If I ask a student to do a coding to solve this problem, student will type in ChatGPT, and then ChatGPT will give student the answer instantly. But the answer could be right, could be wrong, most likely to be right. But what did student learn? Actually nothing. The result is student does solve the problem, but are students learning something? Maybe not. So we should use AI for educational purpose responsibly.
Okay, my name is Jacek, Cracow University of Technology.
Country?
Cracow.
Poland. Cracow is the city.
Yes. And the situation with generative AI is similar to the old situation with graphic tools. I remember when I made my technical drawing by hand on a paper and trying to use the old AutoCAD was treated as a cheating. And similar was with the version of Mathematica when Wolfram was introduced. The same was make an integral by computer was a cheating. We need to teach a student how to use generative AI, how to construct the prompt to generative AI, and how to check the validate the solution delivered by AI. It's our new way. How to construct, how to check, and how to implement a small language model, not a large language model, but try to challenge the student to implement a small language model, their own model.
Okay, well, I have, we have four people that they want to talk. I mean, if they don't talk, they're going to commit suicide.
My name is Stathis. I'm with Michigan State University Extension, but I'm based in Detroit. So nice to see a lot of Midwesterners here. It was just as hot there before we left. I don't want to talk about AI. It is not of interest to me. I am a farmer and trained as a planner, so a lot of what we are discussing, no surprise, I bring it back to our built environment. So just a couple more anecdotal pieces on what Dr. Safiuddin was talking about. From a personal perspective, in 2021, I was working at a teaching farm, and I worked with students, kids really. It was a summer camp, but I was there all year round. I had kids anywhere from 6 to 20. And yes, social media has an astounding impact on their mental state at the moment, but also the amount of social how stunted they are, emotionally, particularly social emotionally. It's evident. It's really evident, and having spoken to a lot of social workers who work there with me as well, they say, that younger students, younger kids, some of them might be a year or two behind where they should be simply from social and emotional learning. And again, from my perspective, we can solve a lot of that by working around our built environment. And kind of segueing a little bit into my talk about tomorrow, I liked what Dr. Gulias was talking about with we need to look at our environment and adapt that to the 21st century. And while yes, a lot of that is using AI and using programming to understand where we're going so that we can get through climate catastrophes a lot faster, I think there's also a much needed healthy dose of taking a step backwards and saying, all right, we built these concrete jungles, but where's the green? Where are our trees? Where are our connections to nature? And that isn't having to map it out and say, all right, let's rebuild the wheel. It's like, okay, well, maybe we need to plant some trees in front of our house and provide kids a place to be kids and to touch the ground. Not revolutionary concepts, things that we existed on for millennia before we reached the fourth industrial revolution. But all that to say, I think it's wonderful moving forward, but then also keeping our back foot firmly stepped on. Like, we're animals, right? We need basic conditions met. That I think we are not even addressing that and trying to run way too fast sometimes, and we need to keep ourselves anchored a little bit.
You want to talk? No?
Yes.
Yeah. You.
I just wanted, Izabela, Stroe, Associate Professor of Physics from Worcester, Massachusetts, Worcester Polytechnic Institution, Massachusetts. And I would like to make a comment related to AI used in the classroom. This is a concern from everyone in physics. I think I have read recently a definition of AI. We should think about AI not as artificial intelligence, but augmentative intelligence, which means that we should use AI in order to develop our creativity and extend our thinking. And I think that is a very nice definition. This is something that perhaps we should teach our students as well in the classroom. And in terms of how do we, of course you can think about, okay, I give a problem to a student, they will go and AI will solve the physics problem. And that's one way of thinking, and that is very scary. But the other thing is, we can use the students to actually help us. Yes, they are ahead of us, but we can use them to help us actually implement using AI in the classroom by incorporating questions during our teaching in relation to AI technology. So we can divide. I recently received a grant from our university, especially to look into how to integrate AI in teaching. And between the discussion between different faculties, we found out a set of questions that we will implement in the teaching and constantly have a discussion with our students about their input in teaching a topic in AI. So that's my...
Okay, you raised your hand at the corner there again.
Yes, thank you.
Yeah, I'm good in
My name is
I'm remotely controlled.
John Ogola from University of Venda, South Africa.
Okay, I didn't hear, you are from the United States?
No.
Oh, good.
South Africa. South Africa. So I'm going to comment on what the last presenter talked about, evangelos. Two issues. Online.
Where are you from?
From University of Venda, South Africa. Online learning and attracting students. I'm going to talk about the experience we had with the cohort of students that we admitted during COVID. We refer to them as COVID students. So they joined the university in 2020, just before COVID hit. Then we went into lockdown, then online learning. So 2020, 2021, all was online. The first time we were meeting them was 2022. In the online period, 2020, 2021, they were all scoring distinctions. When it came to 2022, it was horror, if you know what a horror movie is. So it's like some of the concepts that they should have learned in 2021, 2020, 2021, they did not learn at all, yet they scored distinctions. So it's scary. I know the world is moving towards online, everything online, but we really have to be careful how we are going to integrate online with physical learning. The second aspect was attracting students. Evangelos was talking about the Florida University struggling with attracting engineering students. Globally now, I'm in agriculture. In agriculture, the scenario is worse. We are not.
I missed what you said. The scenario.
In agriculture, the scenario is worse.
We are not getting students, and the ones who come choose agriculture as their third, fourth, fifth option. So they come there. There's lack of interest at all. They're just there because that was what was available. So we are facing a very, very dim future when it comes to agriculture, education, and research. Thank you.
Okay. You want to talk?
My name is Nabil Al-Omaishi. I'm from the College of New Jersey. I was chair a few years back, and I used to invite the Industrial Advisory Council twice a year to talk to us about curriculum, about new things that they want our graduates to learn. And they always said that don't worry about getting or teaching them sophisticated computer softwares. Teach them the basic engineering, analysis, and design. Because leave the computer to us. We will teach them the software we use. People doing highway construction are different than people doing building construction or the technical foundation. So they said we cannot teach them advanced technique in design, but this is your job. Do this and leave the computer to us. And lately we have been trying to also talk about AI and sustainability. The college is pressing us to reduce the number of credit hours that we teach. because we are a state institution and we have financial difficulties to survive. So adding things means that we have to delete some of the important aspects. And probably AI at one time could be taught as elective design class. We have 2 elective design classes in civil engineering. If it could fit because our program is accredited by ABIT, and those who are familiar with the American system of education, ABIT come to us and evaluate curriculum, faculty, labs, everything, and whether they can give us accreditation or they may cancel our accreditation. So we have to be careful if we take AI as a design elective, and if it is not design elective, we'll be in trouble. So we have to take it step by step. So.
Okay, thank you very much. You wanted to again.
So my name is MD Safiuddin. I'm from John Brown College, Toronto, Canada. So I have no comments for AI or machine learning. So I'm scared of that. But I have comments related to connecting research with the industry. Many of our university, even colleges, so they have actually work program, and in my college also 2 semesters we have 2 courses like industry research 1, industry research 2. So in that course we are meeting the student, like group of 20 students or 25 students. We are meeting face to face every week, 3 hours meeting, but their job actually to run a project, they will actually decide the title. We are not giving them the title. The students, they are deciding the title and they are going to the industry. Some of them may be already working in the industry, if not, so we'll help them, giving some connection. And first semester they do like literature review, they do the connection with the industry persons, and then they start their research. And second part, that's the part 2 course. So part 2 course, they are getting the results and analysis. And these 2 courses is 8 months long. So they start in the fall, finish by the end of April. And many students we actually found, so before they graduate, they actually get the job offer from the same company or maybe other company related to the project that they are doing. So in our college, so when I was doing my studies, so most of them working like in the second year, third year, fourth year. Even after graduating, maybe some of them not getting the job. But in my college, many students, I found even in second year, third year. One time I found first year student, working in an engineering firm, maybe having some experience from the back home, but continuing the education from the first year and also the working, full-time working, and then asked me for actually helping him, like if he cannot cannot be active in the class, then whether I can help in different ways. Like sometimes we actually approve that, so that's a kind of accommodation. So my key point here, if we can connect the industry in our curriculum that we have 2 courses, might be very useful for the student for their the getting job in future.
Okay. Thank you.
So, just briefly, and I think this is
you're well known, but we need your name.
Yes, absolutely. So I'm Gonzalez. I'm from the School of Industrial and Systems Engineering at the University of Oklahoma, the US. I also work in data science and analytics, and had the pleasure and honor to lead the creation of our new program at the school that is going to be starting this fall, that is on engineering analytics. And this particular program, it really, I had to think hard about the new challenges that we're going to have in the future, and something that I think it connects very well with what you have said is that, so I think it's important that we adapt the classrooms and the curriculum, but I think we should really think even beyond this, and think if the very concept of the schools and universities that we have is still going to be relevant in the future, or if this is going to, we're still going to have classrooms like we have lecturers and professors leading like teaching. I think the technologies that we have right now, they're changing and advancing way too quickly, and I think it's important that we acknowledge that if we try to maintain the structure that we have and just sort of adapt to the new technologies, they may become obsolete very quickly. So it's important that we think really of maybe building new infrastructure like for education, and I'm talking not just buildings, but like the actual structure of how we envision education in the future, because I think it's going to change beyond what we are even thinking right now.
Okay, I'm tired. I'm tired. Because I came, what, 7 o'clock in the morning here, and I'm still watching and seeing and okay, the idea is, as I said, even though in physical terms it was not a round table, in conceptual terms it was a round table, like people who run around and take people. And of course now you can pinpoint some people that you think you share something. So tonight, during the Greek night of tomorrow, during the dinner, you can sit next to him here and bombard him with questions, with whatever you want to say. And if the other person gets drunk, then I think you're very effective. Dimitri, you want to close this? You want to say something? Because I see your
no.
Have the last word. Say congratulations. Have the last word. Congratulations.
No, these are, I think these are all hot topics and concerns. I think AI has to be seen as a tool, as we have seen Google Chen when it came out. I remember I was taking my first statistics course, and there was a faculty from math, and everything was done by hand. And then Minitab came out, and I was concerned, wait a minute, how are you going to use Minitab? You don't know statistics. And so you have to see it this way, you have to see it as a wise educator, is that it's just another tool. And we have to sort of tailor ourselves to how do we control it and so on. The important issue, that's not my concern, the important issue is what was raised before on the fundamentals. This race of reducing credit, we passed from 136 credits to 122 credits. 50% of the curriculum is general education, and I'm not commenting what that courses are. So the question is, also we face that as we're changing the curriculum, is how do you keep the fundamentals? There is a solution to that, but before I say that, very often we go to the recruiters, to the companies, and they say, what type of engineers do you want? And the unfortunate thing is that they want engineers that they use tools rather than fundamental knowledge. And you raise this question with them and say, wait a minute, how he or she will know to design a bridge if he doesn't know the fundamentals? Say, oh, don't worry, we'll learn it on the job. I say, what? This is crazy. So they want technicians, they don't want engineers, and that's a big problem. And so how do you solve this? In our new curriculum, actually we said, forget the traditional way of teaching, we do projects. From the beginning of the semester to the end, they will have a project. If they are good in statistics, we'll find out. If they are good in statics, we'll find out. And so it becomes a bit more demanding for us, but maybe that will work, I don't know. And the other thing we're concerned more of all is the social implications, mental health. I can tell you, when I meet with the parents, there's no regular student anymore. Every kid is a special student. So what means special? What means regular? And then I look at my classroom, and I look probably one third of them. They have social needs. What does it mean? They need 50% more time to solve a problem. 2 times the time to solve a problem. I say, what happened here? Why? And I think it's related to the social media. That they are so much concerned about the social media and less about their education. I ask them how much time you spend in learning and how much you spend in extracurricular activities. And the balance is 37. And you say, wait a minute, you're at the university. We are not here for the social media, you're not here for the extracurricular.
Don't blame the social media. Blame
Exactly.
the teacher.
Blame the teacher. And so the problem is, if there is a white paper on all of these ongoing implications of the social media, we want to know. And we're going to promote it in our universities. And maybe we create a movement of how do we go about keeping liable the social media, what they do to the kids of others, of course.
Okay, thank you very much.